this lecture, we will cover important logical functions. We begin by discussing the logical test on single argument, that is, if one particular condition is true or false. Single argument test can be implemented very easily by just typing is equal to, select the cell and apply the condition. In this case, we want to identify if any student has scored 100 in maths or not. So we type is equal to, select the cell, is equal to 100. Extend this for other cells. We see outcome is true for only one student, the student 4 who has scored 100 in maths. When we have two or more arguments, two situations arise. Either we want to check that all arguments are true or not, or we want to check if any one or more of the arguments passed is true or not. If all arguments are to be true, we use AND statement. For example, if we want to identify students who have distinction, that is they have scored 75 in all the three subjects, we will use is equal to and enter all the three conditions separated by commas. Extend it. We can see that three students have more than 75 marks in all the three subjects. If we want to check truthfulness of any one or more of the arguments, we use OR. For example, if we want to identify students who have failed in any one or more of the subjects, we use is equal to OR and enter the three arguments. We extend it. We can see that only one of the student has failed because that student scored 30 in English, which is less than 35. Let's move on to the next formula, which is the if formula. This formula uses the outcome of the logical test that we discussed previously and gives predefined outputs for true and false outcomes. For example, if we want to assign grade to students basis their math score, where students with equal to or more than 75 marks in maths has grade A, else has grade B. We do this by typing is equal to if the logical test output if true, output if false. Extend it for other students also. If we want to do multiple logical tests in sequential format, we can use nested ifs. Nested if means that within one if statement, you use another if statement which will be called basis the output of first if. It will be easier to understand this using an example. Here, if we want to grade students as A if score is more than equal to 85, B if score is between 60 and 85, and C if score is less than 60, our first if will check if it is more than 85. If true, we write grade A. If false, our second if, which is the nested if, will check if it is less than 60 or not. If it is less than 60, then grade C, else grade B. We can further have more ifs if we want to have more checks, such as to introduce grade D, we can further have another check of 40 marks. Try to do that yourself. We can also have and or within the if statement if we want to check several conditions at the same time. In the previous sheet we used and or, which was giving us true or false as outcome. Now using if, we can have particular output to these outcomes. If true, We want to output pass with distinction, else nothing. So let's apply this formula. Passed with distinction. For OR, we will have if true, output will be failed, else we will have promoted to next class. So we'll write OR the three conditions: English less than 35, science less than 35, maths less than 35. If true, failed, else promoted to next class. Extended for other students also. The last student 5 has failed. All the other 4 students have been promoted to next class. Next we move on to Countif function. Although this is part of statistical formulas in the formulas menu, but we will discuss it with the logical if formula only due to its similarity with if function. Countif returns the count of cells which satisfy the given criteria. Here, if we want to identify number of students who have scored grade A, B or C in every subject, we type is equal to Countif, then select the range, comma, mention the criteria, enter, extend it for other grades also. So whenever maths grade matches with A, it counts it as 1. So we have 3 students with grade A, 2 with grade B and no one with grade C. Similar operation can be done on other subjects. Remember to put $sign appropriately before extending the formula. You can refer our previous lecture to see how to put $signs in the formulas before extending them. If we want to have multiple checks while counting, count ifs can be used. To implement count ifs, we type is equal to count ifs, first range, first criteria, then second range, second criteria, and so on. So to get the count of students with distinction, we use countifs as follows: is equal to countifs m5 to m9, select the criteria, then the second range, select the criteria, then the third range, select the criteria, enter. The advantage of using countifs is just by changing the value in this cell, which is the criteria cell of 75, we can change the criteria of classification of distinction or not. We can see that no student has scored more than 90 marks in all the 3 subjects. However, countifs only gives us the count. It does not tell you which student has actually passed with distinction, which we found out earlier using the if statement. Next up is SUMIF formula. This is also not part of logical formulas per se, it is under mathematical formulas, but let's cover this also with if and countif. SUMIF is similar to countif, the only difference is that it will add the cells which satisfy the criteria instead of just counting them. For example, if we want to find sum of marks of students in maths who have not failed, we start by typing is equal to SUMIF. First select the criteria range, which is the fail column. Then specify criteria, which is if false. Then specify the range, sum range, it is the math score of the students. This has returned 349 as result, which is sum of math scores of students who have passed the class. That is the first four students, 99 plus 65 plus 85 plus 100, which is 349. Similarly, you can find this for other subjects also to fill this table. Like we discussed Countifs, I would encourage you to explore some